Okay, so this final video is going to see us put everything all together that we've learned in this entire lesson. So it's going to see us put together the rational root theorem, Descartes' rule, the remainder and factor theorems, and also what we know about leading coefficients and the degree of polynomials. Okay, so let's get started. So Descartes' rule is what we'll use first because that's just the easiest thing to do. So how many sign changes do we have? So we start positive, switch to negative, stay negative, switch to positive, and we have 2. So that means 2 or 0 are going to be positive, right? And because this is a third degree polynomial, we have to keep in mind they have to add to 3 in total. So now let's look at g of negative x. Ugh. So that would be negative 2x to the third minus 4x squared, that's unaffected, plus 8x plus 10, also unaffected. So we're starting negative, staying negative, switching to positive, and staying positive. So that means 1 or 0 are negative. So all in all, we must have 2 positive, 1 negative. So 2 positive and 1 negative. And we could have figured that out just from the beginning, right? Because 2 only plus 1 is going to give us 3. Okay, so then on to the rational root theorem. So let's go ahead and establish P is equal to 10, Q is equal to positive 2, P over Q is going to give us our possible rational roots. So we have plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10 for our rational roots for P. And for 2, we're just going to have plus or minus 1, plus or minus 2, and that's it. Okay, so we're going to get a whole crap ton from just having these, right? So we're going to have 1, 2, 5, and 10. And of course, we know these are all plus or minus. Okay, and besides that, see if I can skillfully erase these. We know we're also going to have, so 1 half, 1, 5 over 2, and 5. So 1 half, so plus or minus 1 half. We're going to have plus or minus 5 over 2, right? 2 over 2, well, that's the same thing as plus or minus 1, so we're not going to worry about that one. And 10 over 2 is the same thing as plus or minus 5. So those are all of our possible rational roots. Okay, so a whole bunch. So I'm going to go ahead and erase, give myself some room, and I'm going to rewrite these guys. Or maybe, I don't know, let's see, maybe it'll let me select these. Yes! Let me just move these up. So those are my possible rational roots. Okay, so if we just keep going, so use the remainder theorem. So we're going to go ahead and just try to find which one of these will work. I always like to start with the plus or minus 1 because usually you get lucky and that ends up being one of them. So that's exactly where I'm going to start. I'm going to start with x minus 1 and therefore k equal to positive 1. Okay, so let's see if that works. So I'm saying k is going to be equal to 1. And I'm going to write down my coefficients 2, negative 4, negative 8, and 10. Okay, so bring down the 2 times 1 is 2, negative 2, negative 2, negative 10, and eureka! Got it on the first try, thank goodness. Okay, so that means x minus 1 is in fact a factor because I have no remainder. Okay, so that means x minus 1 divides evenly into g of x. Okay, and that also means that it reduces it down to 2x squared minus 2x minus 10. Okay, so if I set that equal to 0, so that brings us down to number 4. If I set that equal to 0, and I'll go ahead and use a different color here, why not? I'll use blue. Okay, so if I set that equal to 0, like how I did here, I can probably get away with using AC grouping. Let me see, 5 and 4, 10 and 2, never mind, no I can't. But actually, I can divide all of this by 2, if you haven't noticed, right? I can divide all of this by 2, and I just have x squared minus x minus 5. Okay, so that makes this a lot simpler that I can, do that. Okay, so if I go ahead and uh, just solve this quadratic, and I wish there was an easier way to do this one. I'm just going to complete the square because I don't have a whole lot of room to do the quadratic formula. So I'm going to say that this is now going to be x minus 1 half all squared minus, that would become 1 over 4, and then 5 with a denominator of 4 minus 20 over 4. Ugh. So this is going to be ugly. I'm obviously going to have irrational roots after this. Okay, so if I just continue, okay, so this is going to become negative 21 over 4. This is going to become plus or minus the square root of 21 over 2. All of that plus 1 half. So 1 half plus or minus the square root of 21 over 2 is going to be equal to x. Okay, so that is horrible looking, right? So what I am going to do, I'm going to cheat a little bit and make sure that I didn't make a mistake. If I made a mistake, then I'm going to have to re-record this video. Yay! So let's see here. 2x raised to the third, because I'm pretty sure that this wasn't supposed to work out ugly like this. Oh, it definitely is supposed to work out ugly like this. Okay, so I got suspicious and checked my work. Okay, so here's my x-intercepts. So there's the x minus 1 there, right? So x minus 1 means I have a root of positive 1. Okay, then here's my other ones, right? So if I just kind of do square root of 21, really, of 21, and I do over 2, and I do 0.5 plus that. Well, I have 2.79, and guess what I have over here? 2.79. And if I change that to a minus, right, there it is, negative 1.79. Okay, so I did not make a mistake. I guess I made a mistake when I made up this problem. But anyway, the point is, those are going to be my x-intercepts. There was only one rational root in this case, right? But all the same, this is how it comes together. Okay, so what happened to my stylus? My two irrational solutions were negative 1.79 and about, uh, was it 2.79? I already forgot. That is the wrong. What happened to my Desmos graph? Did I close it? No! I did close it. Anyway, it was positive 2.79. Okay, so that means I have one positive, two positive, which is exactly what Descartes Rule told me, and I had one negative, this guy right here. Okay, so that's how we put this all together and can figure out the x-intercepts by hand. Of course, as you just saw, it's always pretty nice to just cheat and use calculators a little bit. All the same, though, I expect you to be able to at least do the basics of this. Okay, so if you have any trouble or have any questions, shoot me an email. Otherwise, you know where to find me. Goodbye.